All right. It's working now. Did I share my screen already? I think I did. Yeah, cool.
Yep. Yep.
All right. So, yeah. Can you see if it's working or not now?
I can
Not
see
sure how
it
you saw
now.
it wasn't working.
Yeah,
Cool.
I've realized on Twitch Studio, if it happens, then when you speak, basically I've got two audio levels going, and I can see your
Yeah,
audio level. So when Twitch isn't capturing you, it just shows it as zero. So
cool. Um,
crypto code got
should
it
be
at the
working
same
now
time.
then.
Yep.
So, yeah. So do you think we should just rename B to C or just keep on using B? Just leave a comment, say, okay, B is now the same thing. We just removed B.
I think
Um,
I was going to suggest that that's actually okay. B is the index after A. So if we're
yeah.
still using A, then B makes sense.
Um, now on B, or let's just do it like this. From this point, physical node,
Yeah.
um,
The main
node.
risk is if we start to access remaining B, those kinds of other things, then it's those cached variables.
Yeah, this was where this is
Yeah.
where it'd be bad.
Yeah.
Um,
But I'm
but we've already
thinking,
gotten rid of that.
yeah. Okay. I'm thinking we can clean that up. We basically just need to separate the scopes. Maybe using it like uh, um, a sub-function or something so that we,
I think here we could actually calculate a length instead of a slice, and actually
okay,
do two lengths here instead of two slices. Except we
yeah,
won't have a pointer that's dangling around. We'll just have the pointer only inside the scope of this function call. That
yeah.
should fix it.
It's just
Um,
what I was
you're right.
thinking is a way to even hide anything referring to B that's not the index, so that we can kind of do this mem copy and the counts inside a helper function, and that way there's nothing leaking into the scope.
We need to do that. We need to have these variables here to do this comparison.
Yeah, so what I'm thinking then is maybe after this, what's inside here is going to be refactored out so that it can't see
Okay.
the
Um,
one way or
should we
the
just write the
other.
code first, then come back
Yeah,
and do this refactoring stuff?
yeah,
Okay.
that's what I'm thinking. I just mean eventually we can like fix that up by just keeping it totally different scopes.
All right. Something's like slightly weird with your audio. But I'm not sure what. It's just like feels like it's clipping or something.
Testing,
I don't know.
testing.
That seems normal. I don't know. It's just like sometimes like when you talk, it's sometimes just like a little bit staticky something. I'm not sure what's going on. I
Okay,
don't know if you changed anything or not, but
no, no, nothing at all.
it just happened again.
Let me change my.
I don't think that's on my end, but I don't know.
Okay,
It's not terrible. But I can manage to just ignore it, I think.
yeah. Okay,
Both
cool.
sounds good here, says CryptoCAD.
Yeah.
Okay, I think that is on my end. You never know.
Testing. Yeah.
I can turn you down. Oh wait, hold. I think I can turn you down within Discord. Maybe this will help. Um. All right. Oh, we try that.
Testing.
It's still kind of weird. I'll just go with it there. It's not too bad. If
Okay,
it says it sounds fine on stream, then that is fine.
okay.
Um.
I get a little bit of feedback from
Okay. How about now?
testing. Okay, all good.
Cool. Refers to a different. But it is still the node. Physical node's not the right. I want to say that it refers to different memory. And node in the different node memories. I was just say, I guess. Node.
I think what we could do is this whole branch we could refactor out.
Can we just keep on working and get the code done, then refactor it?
Yeah, no, completely.
I think because this stuff shares a lot of code with this stuff here, and so
Yeah.
maybe we do want to refactor that.
Oh,
But I'm not sure yet. I think I just want to see all the code at once so we can really see what we're working with.
yeah.
Cool. So now we've got B here. B is less than node count minus 1. So B could be the last node. This comment's like kind of weird. I'm just gonna leave the comments like being weird now, I think, and like bolt that up into the refactoring.
Yeah.
We're gonna just delete it for now because it doesn't really make sense in this context. We can add another. You can add it back if we need it. Array index is cursor.node. This is wrong. This should be B plus 1. Array.node count. Okay. If node capacity is 2 and the node was half full, is B.
You know what, Isaac? There's something odd here. It seems like remove empty node, then we go and adjust indexes. After
We actually don't need to do any of this stuff.
Yeah, we've got a bug. We've got a bug here. So because we adjust the indexes, so B is now C, and when we adjust indexes, we don't correct the index for C after removing from A and B.
Okay, so that is wrong here then.
Yeah.
So it should just be B, not B plus 1.
Yeah. But I'm wondering in remove empty node at, we don't do that there because it is already empty. So maybe
No.
what we need to do is move this up before we remove the empty node.
Why? What's wrong with doing it here?
We can't actually because we are decrementing and it's an empty node. So, we
Yeah.
can. We can because the indexes are absolute, so we can.
Yeah, it doesn't matter though, I don't think. I think having it here is fine. I think this part we don't need because, or actually, can it be the case that both A and B end up with 0? Yeah, it can be. So we do need this part.
Yeah.
That would look like this, where we have, this is a very edge case, but that'd be like where there's just red. It's less than a full node, but so they'd have to both be exactly half full is what it'd have to be. You have two, that's like the most edge case of edge cases in this, but you've got two nodes that are exactly half full, and we remove exactly those two halves, and it's our total node capacity that we're removing.
Yeah.
That can happen though.
Yeah. Yeah, it can. Good catch. Where we update indexes, we also can no longer decrement by 1. We have to decrement by the actual elements removed.
Indeed. I think I've messed that up here too, haven't I? Elements removed is count. Is this correct for the B now? We start at B up to node count. And I don't think we actually don't need this if anymore either, because we're not starting at B plus 1, we're starting at B itself.
Yeah, otherwise it's incorrect as well because we will not update. I think we must just quickly do without a comment, just say const C equals B, and from here on just use C because calling it B confuses me.
Okay.
Then we would also see that that B+1 bug here as well would have been easier to see. So
So C can be the
C,
last node.
yeah, in our assert we've got a bug as well. So C is an index, and we're comparing it against a node count. So we have to do a less
Yeah,
than.
but it can be the last node. Okay, but yeah, you're right. So C is less than. Yeah. Okay.
Oh, what if
So
B was the last node?
we still want to update this index, so we just need to get rid of this if. Oh, you're saying, oh, we were already, B was the last node, we removed that.
Yeah, so C
What you're
doesn't
saying.
exist. Yeah, we could assert that C. Oh, that's another thing. When we remove empty node at, that's going to change node count. It could decrease node count so that our assert will fail because there is actually no C node.
Sorry? Yeah.
Uh,
So, yeah.
so like on
I think
line,
we just need to, yeah, I'm thinking we just need to return it now. If, if B was the last node, we should just return now.
yeah,
So, if C equals, um, return, there's nothing else to do. How's that? And now we can assert that C is less than node count. And then we do need to update. Yep, this works. Yep. That's not correct because we do want to update C if it's the last node.
yeah,
Um, cool.
that's right. Yeah, and we go up to node count.
Yep. And we just subtract count from each
Yeah,
index. Cool. Then what about this case? Counts C can be 0. Well, actually, we're looking at B though, aren't we? I feel like we should be looking at B here. Or A here, sorry. That's just wrong. This should be A, shouldn't it? Counts A equals 0. Then assert either A is the last node. No, because A can't be the last node. So we can only get to this branch if we're moving from 2 nodes at once. And so this case where I was talking about can happen. This is the only case, though, I think, where we can end up with this
both.
node,
Yeah,
if both nodes being empty. Yeah. So this means that, yeah, there's the case that where this could also be 0, in which case we
yeah,
would then remove A as well.
yeah.
Maybe we should handle this before we update index. Actually, updating indexes is fine to do. We need to do that anyways.
I'm
So yeah, this is fine to
thinking.
do here. If A counts that A equals 0, then assert that A equals node count minus 1. What about this node capacity equals 2 thing? That can happen too, right?
Yeah,
Actually,
yeah,
I think we just can't assert this node capacity equal this thing. This can always happen. It's not just for these two things now because we can remove up to half. And so like this situation can happen for at any point in the array. This
Yeah.
doesn't have to be at the end or only if no capacity is 2.
No.
So we just
I
have to get
think
rid of the assert.
I think we should handle that case totally separately in its own branch. So we don't have to
Sure.
special case all the way through the rest.
We don't special case. We're not doing any special casing here. It's only in this branch that can happen. Where if you want, if you want to, we can do this. Like if remaining a length equals 0 and remain b dot length equals 0, else, and here we just remove it to both nodes.
Yeah.
Then I think it's not really worth having a second branch for. We can just handle it with this one check here. If array that counts a equals 0, remove it and don't do any assert.
Okay, but we have to do a separate. We have to do. Okay. Yeah. Okay.
What do we have to do separately?
No, it's fine. It's because we copy from B to A, we do a 0 copy, so that solves the A case.
Yeah, that doesn't
Yeah.
that's fine.
Yeah. No, what I was going to say is we have this branch here, array counts A equals 0. It's almost like we have it again for B, except we don't because we're moving B here into A.
Yeah.
Yeah. How are you feeling about this approach so far? Are you happy?
Yeah, I'm pretty happy with this.
Yeah.
I just want to document this and say if A and B are both exactly half full and cursive index well, relative index is 0 and count is node capacity.
Yeah. I think we should try and group it so where we remove the node for B, we should remove the node for A as well.
I think we can assert these things here actually.
Because you see, the reason is because it's getting tricky. Like we've got on 417, we've got an early return. So if we hit that, then A will stay empty.
Yep, I see that.
Yeah,
So we definitely need to bring this up higher.
yeah. If we keep it together, then we can't. It's less chance that we get that. I'm just feeling that within this branch, I know we just want to flesh out the code, but it already seems like very difficult to get right.
So let's just do another branch then.
Yeah. I think it's it's the BC thing.
This thing? I feel like this isn't too bad, but you're right that we do have a bug here.
Yeah.
So we could just, instead of returning early, just fall through and just skip this check if array equals nodes count equals node count.
Yeah.
So removing A, we can do this earlier though, can't we? And A's also gone though.
Mm.
This is kind of tricky. I feel like maybe having a separate branch for this part isn't too bad. It would be a
Like
pretty simple separate branch.
like to start off with, just to be exhaustive, we could even use very simple conditions. So we could say, if remaining A length is 0, then go into that branch. If remaining B length is 0, but maybe that's going to be overkill because we're just gonna explode all the
Well,
stuff we've got to
this is
handle.
the branch we would be able to remove both of them.
Yeah,
That's the only case where we can remove both of them.
yeah.
But you see, we could also just assert those things here.
Hmm.
Like here we can assert that remaining A length is 0, remaining B length is 0, grocery relative index is 0, and count as node capacity. So I think that's actually better for our codes like inflexibility, because then we handle it. I guess we can
I
assert that stuff in here too.
I think it's better to this is such a unique case, so I think it's better just to handle
Yeah.
it by itself. And then the other
And then
case
here we can assert
we
that array
need
that counts A is greater than 0.
exactly, yeah.
Um,
Then it just becomes much easier.
yeah, I like this better.
Cool. And
We don't have to worry about the early return
we
and
can
this stuff.
even at this top of this branch we can assert that remaining A length is, oh, you see, that's another one. A might be 0 length, but then we're going to move B into A, so
They
that's
can't both
okay.
be 0 length though. No, we've done this. Yeah.
Yeah, yeah,
We'll
but
always
even
have, this is
if,
always true. No.
yeah, that will be fine. So you see, we're actually doing an unnecessary copy there as well, because we're copying B
How
into an
so?
empty A.
Or we're not going to move it again.
No, so check out on 411.
Okay, but we already have to copy B, potentially. There's a very slim case in which we don't have to copy B there. I think we're almost never going to hit it. The only
uh,
case where B is already at the start of B, but actually we won't even hit this case then, because then you're already going within one array. No, we can't hit that case. You hit this case instead. In this case we know that B is not at the start of its array. It can't be B can't be right at the start of its array because we know that we've got red in both nodes,
yeah,
and so
we've
we
got,
already have to copy B either to here or to here. We have to copy
yeah.
B once no matter what we do, and so there's no necessary copy there. Um,
Okay, so whether we copy it to another node or in the same node is fine.
it doesn't matter. It's still one copy.
Okay, so that one,
You want to stay here, or what
yeah,
are we doing now?
thanks. Yeah, yeah. The next one just below that, there was the
This
other,
here?
yeah, there was the other one where if A is half full after deleting red, we've decided we don't want to copy B into A. We'll rather see if we merge it to
Yeah,
the right.
that's this here.
Okay.
And
And
so
what?
then,
I just want to understand that one a bit, just again.
so that one, whereas we wouldn't hit this case because B won't fit into A. This doesn't fit there. And so that's the case we haven't done in code yet. But what we're going to do is we'll just leave this node alone. It's already half full. It's fine. Um, and we're going to copy this to the start of this node, and then pass this node and this next node to our merge next node function. And then this will get merged as
Okay.
necessary. And this stuff won't be copied again because it's less than half full, and so there's no case in where this stuff will need to get copied out of this array to the next one.
Okay. So
Um,
that's the advantage there. Okay.
yeah, so there's
Yeah.
still only one copy there. I'm pretty confident that there's no case there. There's more than one copy now.
And
Um,
Isaac, I just want to just understand like fully. So that last little bit there of purple, Why,
This bit here.
yeah, why don't we want to top up A completely? What's wrong with that?
Um, Simplicity is one reason.
But
It's
in,
already half full, so there's no need to touch it. We could copy like half of it or most of it into there and then leave a little bit here,
yeah,
but we don't have to do that. And
but
so,
my point is that there is no, it's not a mem copy argument against doing that.
sorry?
We moving B all the way into A to fill up A totally. There's no, it doesn't add mem copies doing that.
No, it wouldn't.
No,
We could do that if we want. It's
because
irrelevant to the surrounding control flow though, because
okay,
what you'd
because yeah,
yeah.
because earlier that's what I was thinking we should do, because if we do that, it is actually simpler because then we can do the pipeline. We don't need all our branches. We literally just have the slices and we just pull them all the way to the left and then merge with the
We
last
can't
node.
we can't do that in this case though. We can only do that if A is already half full. Well, no, because then you can end up copying. So, hmm, where's the case? It was this case, or
Yeah, I just wanted to understand it again, just to check that there isn't there there was a copy. Because this one is fine. This one
and
we
so well, so here we could copy that over. I think that's not really relevant to the larger control flow though. That's not going to make things drastically simpler because you still have to then leave this bit of B here behind that you then copy the start of this. And
it
so it
can
actually be making it more complex by doing an extra copy.
no
Well, it's not
I
an extra
just
copy in terms of the copying data, but you're copying you're doing splitting this in half instead of just copying it once.
no
And so it means more complex control flow.
I don't think so. I actually think we can have way simpler control flow. That's why I like this idea because it's literally just compacting stuff all the way to the left. There's no extra copies, and then we just merge with the node on the right.
Can't do that in
Whereas
this case though, I don't think. There's one case where that doesn't work. Hold up, where is it?
that's what I wanted to just find that counter example just to check that we've got it.
I already found it once. I'm just forgetting what it was.
I think the counterexample that you raised was actually this case, but we forgot that we have to shift it within the node anyway. I think that's what we missed. You see, we thought that if we're gonna compact it to the left, now we've got to copy B, but actually we have to copy B within itself anyway to shift because we've always got a bit of red at the front. I think that was the counterexample, unless there was another one.
I've messed up this stuff here, so let
Because
me put that
then
stuff back.
if we do that slice approach with just a slice of source streams and a slice of targets, then we don't actually have any branches. It's really very, very simple code.
So here's the case I found the counterexample. Um, Here it is. So here we've got two nodes where the nodes individually are less than half full, but together they're over half full. The purple parts individually are less than half full, but together they're over half full.
Yeah.
This is where you copy data twice. And so I'm just going to make this a little bit more.
Okay.
So we see that these purple things together are both less than half full, but together they're going to be over half full. And then you're going to have to copy data twice.
Can you show me again? So purple are both less
Yeah.
than half full.
Yep. So these purples are both. Why can't I copy? There we go. And so if we did this, we then end up with a node that's over half full.
But there's nothing
But then no, never mind.
that actually
That's actually
saves a
fine.
copy because we don't then have to merge with the right. And we do have to copy that anyway because we have to shift it. Whether we shift
Yeah,
it in the
never
same
mind.
mode
That's not the counterexample then.
yeah.
Hmm.
If we can find the counterexample, it would be great.
So for this case, you just copy. Well, this one already fits in there.
Yeah.
This was bigger though. Just trying stuff out now, kind of.
Yeah.
Now, this is then the case where this one is smaller than half, the other one's larger than half, and the two of them together are more than a node in capacity. It's kind of like the opposite of this case. But then you're gonna get this doesn't fit here. Then you just like, I guess you could just copy the first part of it there and then move the little bit here, then merge these two.
Yeah.
Then okay, so that's the problem then.
Yeah.
Because you don't actually have to do this.
Yeah.
You don't actually have to copy this data then.
That's it.
So if we do this properly, that's it. Yeah. We don't actually have to do the second merge if we do this properly.
Yeah.
And we do the merge on these two things because if they both are more than half full, because we don't want to copy this data if we don't have to. That's what it was. This is kind of tricky.
Yeah. Okay, cool. Thanks that we could just like reinforce.
Yeah, no problem. I'd forgotten what it was myself, obviously. So
Nice.
It's good to have that in mind. Remember why we're doing what we're doing.
Yeah. So basically, this would happen where the remainder of purple are both individually, they're both confident because they're more than half a node. They're at least half a node, both purples.
Yeah. So it's actually easy to explain in this case too. The thing is, we don't want to copy. This is a better example, perhaps.
Yeah.
In this case, or maybe this one works too. We don't want to copy, do anything with this node if we don't have to.
Yeah.
And so,
exactly. I think I've got the control flow for us. We only need two branches. The one branch is a special branch where we check the remainder. Remaining A is greater than half, greater than equal to half. Remaining B is also greater than equal to half. Then we handle it where we just shift B internally, and then we're good. We don't even need to merge. And then otherwise, all the other cases are handled with a single branch where we just shift everything to the left and then we merge. It handles all the other, there's no, like literally our control flow then is just one if and an else. And we just always shift to the left like that.
Cool. And so, so the case where we would have to then, where we end up causing an extra copy is when these are already both greater than half.
Yeah.
And so it would be more efficient to just do this one copy instead of splitting this, copying half of it there, then copying half of it here, and then copying stuff from here.
Yeah.
Then you do more copies.
Yeah.
Otherwise, we're just going to chop off a bit of it here, put it there, the rest of it here, put it there, and then merge the last two.
Exactly. So we can make that special case as an early return because we know we don't even have to merge. And then otherwise we just call through and we have a single merge path right at the end. And it's literally just that ball bearings pipeline. We just chuck everything to the left and that's all fine. There's no extra copies
so
then.
Hold up, because there's also like this case though. In that case, we just copy because we have to delete the nodes.
So I was thinking we make it like a generic kind of algorithm. That's why we do it in terms of a pipeline, like a slice. So we just fill up the slice. We fill up the array with slices of data, and then we point it to a start node, and we just copy into that node, fill it up, go on to the next node, fill it up, fill it up. If we need to.
And helpful way to think about it, but I think in the code that's going to make things really complex because we actually we don't need an array. We just have three things. Which kind of like
along. I'm with you then. But it's just that that's what we do, and then at the end we merge if needed to. Just so that you see, I thought of it that way because sometimes we only deal with one node, and sometimes we deal with two. But actually, we always deal with a certain number of slices. That's the key.
Exactly. There's always like 3 input slices.
Okay,
like
cool.
This one, and then the next node.
Yeah.
And so that's why we've got this merge algorithm the way we have it right now, where it just takes a node and a slice of elements in the next node, and then deletes the next node or fills it up and fixes the thing. This algorithm's got the perfect signature. That's what we want. We just need to figure out. We're still just figuring out how to feed stuff into that algorithm properly.
Yeah. So
Um,
we basically just
I
need
think I really think we should just keep going with this code though. I think this code's doing what we want it to do.
no, we can already simplify. Like we only need two branches. Whereas now we've already got five. This whole function only needs two branches.
Okay, so we just try it again then from here.
Yeah, if you're okay with that, and let's keep this code
Sure.
that we've got below. Let's see if we can. I was just finding it too hard myself. Like when we were doing the C and B thing, then I
Well,
couldn't.
I thought we were almost done with it. I mean, I think
Yeah,
there's not that much more to do. I think we could finish this in 10 minutes,
yeah,
or
we
not 10
could.
minutes, but like 15 minutes to like get
We
all the cases done.
Yeah, but if we can do it in two branches, then that's nice.
Oh yeah, I agree. That's better. It's less
Yeah,
code.
yeah.
So what's the first branch?
So the first
Um,
branch is, are there going to be two nodes? Um, the two slices, are they both more than half? So we basically have to always calculate our three slices, our source slices, whether they're in one or two nodes.
okay, so the first thing to do is just calculate the source slices. Then we
Yeah,
do this thing
yeah,
essentially, but
yeah,
then handle the case where they're in the same node as well.
yeah.
So then we need to, yeah, so then it gets a little bit tricky to calculate them, I guess. So we need some branches to calculate them first of all.
Yeah.
Um, why is my VC format not working?
Maybe we'll
Here.
find we're getting back into these branches again.
I think we're gonna have. I think we can make this slightly better though. We'll see.
Yeah, yeah.
So calculating the first one, that's gonna be 0 up to relative index. Is that always right? That one's always right. Yeah.
Yeah,
We always have. It could be 0 length or it could be non-zero length.
yeah.
That's fine. This is the one where you need a branch. Um, we need to see if we're checking essentially this condition and then slicing in one node or the other depending on this.
So maybe we want to do it in three branches rather than two. So the first
So
the
this
first
branch,
uh,
and then this branch, this branch. I mean, what are
no
the
no
conditions
no
for the branch is going to be?
but they should all be on the same hierarchy. So the first branch is the first big question is, does this remove only affect a single node? If it only affects a single
Okay.
node, then handle that case,
This
and
stuff is all
yeah,
good then.
and then fall through and merge at the end. Uh,
Okay. So what's the second branch?
Second branch is now here where we know it affects two nodes, and then now we in two nodes, and now we deal with the special case. So we say, is remaining A greater than or equal to half and remaining B greater than or equal to half? Then just shift B, and then we're done. We don't need to merge. And then
Okay.
otherwise we do the pipeline thing where we just shift everything to the left and merge.
And so we're still going to need these branches there to delete the nodes. Like we're still going to need all this code essentially.
No, no, we
Um,
don't. We don't need like remaining A length 0. You see that what I was thinking is we turn this all into like a generic loop where we take our source and our targets and we move source all the way, increment the node, and at the end we delete the nodes that are now empty. Uh,
okay. That seems trickier to me than this, but I'm not sure. I haven't tried that way yet.
yeah. You see, we could even handle the first branch like that as well, because um, we just literally put all the slices into some kind of array, source
I mean, but
slices,
that would just be duplicating this code essentially. You still need to do this stuff.
but it would then make it general over everything. So we only have to do one
Yeah,
metadata update.
I'm thinking that I'm really thinking we're gonna have essentially the same code, but just with like more cleaned up logic. I think if we
Yeah.
finish this and then refactor it to factor out the common logic, we're gonna end up at the same place essentially.
Yeah, well there is one way where we can have it in two branches. No, we can only have it in three branches. Sorry. No.
And this one we can stick in this branch too, but it just makes it worse actually, because then we can't do
Well,
those asserts.
you see what I think is just like if we literally write like a source array and just push slices in there and then have a target node and then just consume just uh, peek from our source array, push to our target node. If it's full, increment the node. And at the end, we literally just compare our node index with
Okay.
how many nodes were involved, and then we know exactly whether to delete the last node or not. It basically, the advantage is we don't have to do this check, remaining A length 0, remaining B length 0. We only ever remove the last node. So it simplifies all of that, like what we ran into in the middle branch here. That becomes much easier.
Okay. So you're kind of saying we should put new code in here then in this else branch to replace
Yeah,
these ifs,
yeah,
and not up here.
yeah.
We can get rid of that then.
So we handle the single node case separately and get that out of the way. Now we know we're
Okay.
only dealing with two nodes. Then we need to set up like a source stream and push slices to it. Now we don't even think in terms of A and B anymore. We just push our slices all into the stream.
And the maximum length of this source stream is what?
Um, it
Um,
it can only have two. It can only have two things shifting. Uh,
okay. So our sources.
maybe we miss.
Array length 2 of slices equals undefined. Actually, it'll be equal to, we can just make it using remaining A and using remaining B.
Yeah,
Um,
yeah. Maybe I don't know. Maybe it's not necessary, and we can do something of a hybrid.
uh, did I do that type right? No, I didn't. There we go. I'm going to try this,
Okay.
but I also think that this code's almost done, and so
Yeah.
kind of
And
itching to just finish it.
okay, I'm happy that we can do that. The only other thing where I've gone wrong here too is that we need to first handle the case of remaining A, remaining B, both greater than half, greater than equal to half.
Okay, yeah. So that's gonna be a special case. We haven't done that
Yeah,
yet here either,
yeah.
and so
So we
those are like pretty easy cases though, I think.
so we could
Um,
make it like
do you
just
want to?
three cases. We could do single node case, then two node case where both nodes are going to have greater than equal to half, and then finally the last branch we do it like this, or we do it in whatever way makes sense.
Um, I feel that that's almost as like just as many branches as we have already, and so I really feel like we should just finish this code that's almost done, and then try
Yeah,
and refactor that, or see how that makes sense to refactor that.
yeah. Well, you see, we wouldn't have this branch here with the pipeline approach.
Yeah, you're right. I agree with that, and I
Yeah,
think that's one of the branches we would try and factor out.
yeah,
But aside from this branch here, this code is not really that bad. Um,
yeah. But we still need to add branches here as well. Um,
Well, we need to add, yeah,
those,
these ones are pretty easy though, because these ones can't be empty then. Then
yeah,
you already have, and then it's the same as this. And then we're going to see that you can factor this part together with this part down here.
yeah,
That's what we're going to see. So then we're going to have a better helper function. I think we can simplify this code a lot, and then it'll be easier to simplify it even more by changing this if control flow.
yeah,
Um, I'm feeling pretty comfortable with this direction.
yeah.
I think you're right. That we're going to want to get rid of this branch and unify it with this stuff.
Yeah,
But I think I'm not I'm not really comfortable seeing how to do that yet until we factored away like this stuff, and made
Yeah.
it made this part of this tricky logic more generic.
So
I think we will have to do.
that's what I'm also trying to do. This last tricky part to make it generic. That's where I
Yeah,
think
I just want to
we
see all the cases covered in code first, so I can like reason about them better. I don't
yeah.
know.
But we have to make it correct then as well, which I'm finding this is too difficult for me to. Um,
I think well we've already gotten rid of this. This is not too hard. I feel like this case is now got two asserts to verify it, and then all we
yeah,
do is remove that node as well. We just remove both the nodes and set the counts right.
yeah. So, like, just throwing it out, another thing we could do, we've handled the single node case. What we could do next is we can handle the case where both nodes are greater than or equal to half. Could just do that case next.
Okay. Then we just leave this to you for now.
Yeah,
Okay. I mean, this one's like trivial to handle properly. But yeah.
yeah. And then that last branch is literally just shifting everything to the left. But that I feel could really just be a loop. And then we
Yeah.
handle all the special cases just with a loop and it'd be a lot less code. It is kind of one branch, so it doesn't need a helper. It's only one thing.
I think I really just need to see it all written out in code to reason about this better.
Okay,
Um,
okay,
so this branch is remaining a dot length is greater than half, or remaining b dot length greater than or equal to half. So if a dot length is greater than or equal to half, uh, then we're going to essentially just remove or check if b is empty. If so, remove it. Otherwise, merge node with next. If we're going to remove b. And then if it's not empty, we need to update metadata, I guess, too. Well, actually, we've already set counts to 0, haven't we? Or have we not?
yeah,
No, we
yeah.
haven't. So that would mean that, or
Oh, we
maybe we
haven't.
should
Yeah,
set counts to 0 first then.
yeah,
Um, yeah, because then this merged node will use the counts of the node that's being merged into. So if we need to merge it, we'll need to set counts to 0. So we'll do array that counts b equals remaining b dot length, and then we can here use array that counts b instead of this. And if that's 0, we remove it. Otherwise, we merge it. Next elements is going to be same thing pretty much. We're going to be, this is like not, we haven't updated this for this branch yet either currently. This needs to be, it's not cursor at node plus 1 is the issue. It's just B. It's C in this one because we renamed the thing. Next elements is, well, here it's going to be B plus 1. Merge node with next, then we're done. Okay, so that's, now we've handled this branch. We need to update the indexes, I suppose. This stuff we need to like really factor together. Updating the indexes stuff. This
yeah,
one happens to be the same as this branch, I think.
yeah,
Because we have the same issue with the node being out of bounds, or the next node possibly being out of bounds. counts indexes. If we can't do this like stuff up at top. And so I think yeah. And for B, if B is greater than half, if they're both greater than half, then we don't need to do this either, right? Yeah.
Yeah.
So we're just done in that case. We just update the indexes and whatnot. Okay, so maybe we should do it like this. Maybe we should first update all the metadata for these two things. I think if this is the case, then we're not copying from B into A or from A into B. Do we agree with that?
Yeah. I just find it would be so much simpler if we literally just shift everything to the left and then decide if we want to delete the last node or not. Like it's really like 5-10 lines of code. And then
Okay.
all these go, I like personally I
Can we
can't.
try that again?
I,
That'd be just going in right here, right? And
yeah,
then just doing that.
but
Okay, so what do
before
we
we
check
do
for
that,
then?
we just have to handle the special case where A and B are greater than or equal to half. So just deal with that
Both of
case.
them. Okay.
Yeah. And then after that, we just shift everything to the left and then see if we need to delete the last node and then update our um, metadata and then do a merge. It's great that you working out all the the whole decision tree exhaustively, but personally, I'm finding it. I'm struggling to. I just feel like for me it's too tricky, you
It is probably
know.
too much state to keep in your head. I don't
Yeah,
think it's good.
yeah. I give up. So kudos to you for like soldiering on there, but it's just too tricky. Yeah.
Yeah. And it just gets super branchy. I
Yeah.
just kind of realized how branchy it's going to have to get, and I was like, okay, this isn't really good. I think Jordan's probably right.
No, I'm just you're just much sharper, so
And
you could go that far.
if we weren't pair programming, I'd probably just like cruise ahead and finish it, but then it'd be like 500 lines of just super branchy code that needs to be refactored.
Yeah,
Um,
but it's fine.
so I think.
I hope you don't mind like that. I keep wanting to go back to this thing, but maybe I haven't let
Yeah, I think you're
you
probably
finish
right.
it.
I realized it's gonna take more time to finish than I was expecting, and
Yeah,
so I was like, okay, yeah, let's try this. So we don't do any merging in this case. We're done. We just need to update the counts.
yeah, and we need to shift B internally.
Yep. Um, and then so that's the counts for those two, and so indexes of B needs to be updated specially, and then afterwards it's all just plus equals count. So array dot indexes B equals um
It's B's old
we can just
count minus B's
use
remaining length.
yeah, so it's count minus remaining B dot length.
It's array counts B.
Or
Array counts
it's
B
actually, I
minus.
think it's easier to do it like this actually. I think we can do array dot, I think this is more obviously correct to me at least.
Of
You can tell
A.
me what you think.
Oh, way better. Yeah, way better. Like we did elsewhere as well. Yeah,
Yeah, it's
cool.
just obviously correct. Um,
Yep.
okay, and then after that word, we need to update all the rest of the indexes to be like plus equals count.
Yeah.
So I'm gonna grab like this one maybe. This the one we want. I think C can be, or B plus 1 can be out of bounds now because
Yeah.
B could be the last node in the array.
Yeah.
We probably want this one then actually.
Yeah.
Um,
Yeah.
no comments for now. B plus 1.
Have you seen the movie
Okay.
A Few Good Men? I think it's A Few Good Men.
I don't think
there's like an attorney, or it's it's like a courtroom scene, and
12 Angry Men?
no, it's not A Few Good Men. It's with it's a classic. It's with Danny DeVito, and he's like he basically pretends to be a lawyer, but he's not qualified. He's never done his bar exam, but
Hmm.
he's defending his. Um, it's with Marissa Tomei as well as his girlfriend.
I haven't
Uh,
seen this now.
no, it's not Danny DeVito. It's Joe Pesci and Marissa Tomei, and Joe Pesci's pretending he's defending his nephew from like from the death sentence. But he's not a qualified lawyer. But his nephew at one point gets another lawyer, and that lawyer can't really. He stutters, and so in the end they go back to Joe. But at one point, this lawyer says to the witness, he says, no more questions." So anyway, sorry, long story short, but that was how you said no more comments. Yeah,
No comments for now.
yeah, but yeah,
All right, so here we've got b is less than array.node count. Um, that's good. We know b is valid, and then we say if b is not the last node, if b is less than array.node count minus 1,
yeah,
then we'll go from the node after b to the end of the array and increment counts or decrement indexes by count. That
yeah,
updates indexes properly. I'm
yeah,
happy with that.
yeah.
Now, we know that both of these are over half full, so that's it.
Return. Yeah. We
Okay.
should come up with a name for this, but it's basically we're taking some tricky cases, we deal with them, push them away, another one deal with it, and then what remains is then pretty simple. Uh, well,
Hopefully.
hopefully.
So,
Yeah.
equals, this is going to be array. I guess we can just do the 2 explicitly,
Yeah.
just to make it very obvious, of slices of t. These could be constant, I think.
Yeah.
And we have here remaining a followed by remaining b.
Yeah.
Is that right? Is that
Yeah.
what you're picturing here?
Yep.
Except for remaining a, I think we don't even want to have in here. So I think that's what kind of like we start with. We don't want to copy that one, right?
There's actually there's remaining A. Yeah, remaining A we don't need to copy. So we don't, yeah, we
It's kind
can
of like a
leave,
start index though.
yeah,
Or start cursor. Do we like have a cursor that moves?
we need like a target node that moves, or
And a target index within
yeah,
so it's
exactly.
just a cursor, right?
Cursor, yeah,
So current equals what's gonna be a cursor? Node equals a dot index or relative index equals remaining a dot length. I know that's the same as relative index of our current cursor, but I think it's nice to express it like that here. So you
yeah,
see that we're like skipping over the
yeah,
stuff that's remaining in A.
yeah.
And then here, well, we can leave the second one is undefined. I don't know. What do we do here?
That's fine. We only need, so basically what's going to happen is we're going to peek from B and see how much of B can we put into the current node. If there's leftover, we're going to update our cursor and go into the next node.
So do we really need an iterative thing here? Don't we just
We can do it
like
using
don't we just
two ifs as well. It's fine.
like how many iterations are there? I think we should just do this with 2 ifs to be perfectly honest.
Yeah, it's just that at the
Um,
end we want to know which is the node we ended up on, because then
so we
that's
can we can we can we can keep current. We
yeah,
can just I think we should get rid of sources.
yeah. Okay,
Um,
cool.
so the first thing to do we always copy over B then? Can we like diagram this out real quick? So this is like the
Yeah,
case. We've eliminated the case with one node. We have only two. We have 2 nodes for sure. So we've got
yeah,
some remaining A, and it's They're
That's
not
where
both greater than half. So this. Oh, so, but what about the case where remaining A is less than half, or remaining B is greater than half? Um,
we copy it also because we have to copy it anyway.
I'm not sure we do though. Let me look at this real quick. I'm not. I may. What am I doing? Stop being weird. Board thing. Um. So remaining A is less than half. Remaining B. Oh, it's this case, isn't it?
Yeah,
Remaining B is greater than half.
yeah,
But the two of them together are greater than half as well.
that's
And
fine.
so
So we have to shift B anyway within B. So what we do here is we see we steal from B as much as possible that will fit into A, because it's always nice
then,
to compact things.
then what the part that's left over is less than half.
Then that stays in B, just like
But
that.
then
And
we've got to
then
copy this data too.
yeah, then we're going to do a merge. But
But we
we
could have just
have
not copied.
okay. Yeah, if B was greater than half, and A is
We
less
should have
than
just merged
half,
these two nodes. Is what we should have done.
yeah, yeah.
So I think, yeah. So I think,
But it's not guaranteed to succeed because the merge, yeah, we could just merge the two nodes and then see if we need to merge again with the next node.
we no, we are guaranteed to succeed because one of them is greater than half, and that's guaranteed to succeed.
Okay, but they might not always be, but both of them could be less than half.
Right. That's the only case we need to examine here, though.
Okay.
I'm pretty sure. Because if one of them's already greater than half, we don't want to do any copies. We just want to merge this node and this node, essentially. Or, sorry, this node and this node. Or if it's the other way around, and this one's greater than half and this one's less than half,
Okay, so
then just
then
merge these two.
Isaac, we can keep doing what we're doing. We just add a single if to know whether to break. So we just have to change. So if you go back, like how you had the split between A and B with more in B less than A. So okay, so now what we do in our loop, or I'm just calling it our loop, but you know what I mean. It's no longer a loop.
Yeah, yeah,
It's just
sure.
two copies or whatever. Now what we do is we steal from B as much as will make A greater than equal to half.
Okay. So instead of trying to make this full, we just try and make it bigger than half.
Yeah. If it means that B
Okay.
will also be greater than half, if we can get all of B into A, we do that. So we try to get all of B into A, great, then we just delete B. Or just steal as much from B as will fill up A, and then check if we need to merge B with C. And that's it.
Okay, so we check first if all of B fits into A.
Yeah,
If it does, we're kind of just like writing a two-tiered merge is what we're doing.
yeah,
Um,
exactly.
so check if all of B fits into A. If it does, move all of B into A, we're done.
And drop
Okay.
B, because that's first prize as well.
Yep. Right. I think we already have that case in our code right now. I'm just gonna throw that out there.
No, I'm with you. I'm happy. Yeah. Okay. And then otherwise,
And if we don't fit all of B into A, then we fit as much. Then we try and fill up A over half, and then we copy the rest of B to the start of B. So what we do is this. I'm gonna just draw the next step here. Let's delete all this stuff for now, just to make space. Actually, no, the next step would be this. We'll
yeah,
copy these two. Then we copied, this one needs to get split. This will get us to just exactly half.
yeah,
And then the rest of B. Now,
yep,
it could still be over half, or it could be less than half. We don't know.
yeah,
And
yeah.
we kind of check if this is over half or less than half. And if
Right.
it's less than half, we merge
Nice.
with the next one, which is
Yeah,
guaranteed to succeed.
yeah.
Okay. It's
And
really,
then,
this is just a better strategy for solving this part, which I was just
yeah,
like going branch crazy on.
yeah,
Um,
it's fine. I mean, like in the VSR code, I often used to do these branches where you just sketch out all the branches exhaustively, and then um,
okay,
yeah,
yeah,
it's good.
but I think
If we
this
go,
case stays then, right?
uh,
Um,
yeah,
where they both fit into the same node.
yeah,
That was this case where they both, if they both fit in the same node, then we just delete this and we're done.
yeah. And then there's just one more case we maybe need to look at the in the whiteboard. That's where A already has more than half, greater than or equal to half.
And
Um,
B doesn't.
yeah,
In that case, we just want to merge B with this, right? That's
yeah.
what I would assume.
We're still going to try and put all of B into A.
Sure.
We always try that first. Then we see how much can we fill A up. Okay, we don't need to fill up A anymore. Well, I don't know. Is this making sense?
Yeah, that's making sense. That seems like a list of things we can do that doesn't have branches or doesn't
Yeah,
have like it's not like deeply branching. It's like you do like
that's the thing.
you check a series of things in series. I
Yeah,
think that's then
yeah.
easier for us to follow probably
It's a like
instead of just like
it's a flat
yeah.
tree, not
You
a
don't
deep tree.
you don't multiply your cases by your number of things. You keep it
Uh,
flat, and so you don't do
That's it.
like three branches times two branches to get six. You just keep just the flat thing.
Yeah, it's just
Um,
reducing dimensionality. It's like a list of things to do. Yeah.
yeah, cool. I think I could use a 5 minute break. Do you want to like
Yeah, I
come
was
back in five
thinking,
minutes?
yeah,
And
if you like, we could also stop here for the day, because then we were thinking to stop a bit earlier. I don't know how you feel. Then we've
right,
kind of
yeah,
got a good start for tomorrow. I feel pretty bushed, like
I
it's
think we
been
do.
really tricky.
Yeah, I think that's a good plan. We can work on the other stuff we've got going that isn't this part of Tiger Beetle,
Yeah,
and come back tomorrow.
yeah. How are you
Cool.
feeling about how did you find the day?
Um, yeah, it's definitely tricky. I feel like it's harder than insert actually.
Yeah.
Um, but we're better at this stuff now, so we're gonna make it through.
Yeah,
Um,
yeah, absolutely. Yeah. Yeah, well done, Isaac. Like you really, it was pretty awesome how you were powering through it this morning, yeah,
thank you. You too.
yeah. And nice to have
All right.
like
Yeah.
Cryptocode and VS Specky, and I saw Larice popped in as well, Nipsey, like nice to come back again and keep asking nice questions. Yeah,
Yep. Take care and see you tomorrow. I guess I'll sign this off now. The Tiger Beetle sessions, session 15, Wednesday, the 2nd of February. Signing off.